Good morning, class. Today we're going to continue on with our current unit, and we will be talking about the law of cosines today, which obviously from this slide you can tell that you will use the law of cosines whenever you are given three sides, side, 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 or two sides and the included angle between them, which is side, angle, side. All right, so here is the formula for law of cosines. We have a squared is equal to b squared plus c squared minus 2bc times the cosine of angle A, right? Now this is kind of a very specific case, right, where you're solving for side A if you're given side B and C and the cosine of angle A, right, which is your side, angle, side case, right? So, right, if we're given side B, side C, and angle A, here's our side, angle, side, all right? And then, of course, it allows us to solve for the other side. Now, if you're given side, angle, side in some other case, right, like sides B and A and angle C, or sides A and C and angle B, all right, that's not a problem in any way, shape, or form. All right, basically, as long as these two letters match, right, so lowercase here and capital, of course, with our cosine, because our trig functions always have to be attached to an angle, right, and then these two, B and C, have to match up here, right? But you can switch the letters around as long as that holds true, right? So what I mean here is if we wanted to solve for side B, right, then b squared would equal a squared plus c squared minus 2ac times the cosine of angle B, right? That would work just fine as well, right? Again, because B and B here match up, and A and C here and A and C here match up, right? Similarly, you could say c squared is equal to a squared plus b squared minus 2ab times the cosine of angle C, right? That works perfectly fine as well. Again, the C and the C match up here, A and B match up here, right? Now on the formula sheet, you will just be given this one, okay? So do be mindful that it is very easy to just switch it around. Of course, you could also get creative and actually just change the lettering of the triangle to fit it as well, but I think this is probably the easier way. All right, so here's an example. It says solve triangle ABC given that angle A equals 11. That side A equals 11, side B equals 5, and angle C is 20 degrees. All right, so in here we have sides A and B and angle C. All right, so if we have sides A and B and angle C, we're going to be solving for side C right here. Basically, whichever angle you're given is the side that you're going to be solving for. All right, so here we have C squared is equal to a squared plus b squared. Whoa. So a squared plus b squared minus 2bc times the cosine of angle C. So now all we have to do is plug all of this stuff in. So c squared is equal to 11 squared plus 5 squared minus 2 times 11 times 5 times the cosine of 20 degrees. All right, and then of course to solve for C, you would have to take the square root. So whatever you do to one side of an equation, you have to do to the other. And we can go ahead and just plug this right into our calculator like we see it. All right, so we've got the square root of 11 squared plus 5 squared minus 2 times 11 times 5 times the cosine of 20 degrees. Again, we do want to make sure we're in degree mode, of course, but we are, so this is fine. All right, so when we do that, all right, we get 6.529. All right, so there's our first piece. All right, so now we have all three of our sides. We need to find our other angles. All right, well, from here, we can always use law of sines, all right, since we have, an angle and a side that match up and another side. However, you have to be very careful here, right? Because of the way sine works, where sine is positive in both quadrants 1 and 2, right? Now, obviously, in a triangle, right, all angles have to be between 0 and 180, right? Well, that is in either quadrant 1 or quadrant 2. And because sine is positive in both of them, it can actually mess you up, right? Because, basically the sine of 135 degrees, for example, is the exact same as the sine of 45 degrees. Okay, so you have to be kind of cognizant of that. Basically, the way that you get around that ever messing you up is that you always find the smaller angle first, right? Because a triangle can have at most one angle that's greater than 90 degrees, right? Obviously, if all three angles have to add up to 180, then only one of them can be 90 or larger. All right, so if you find your smaller angle of the two, all right, that means that it has to be less than 90, which means you're going to be in the first quadrant, which means it's not going to mess you up. All right, so how do we know which angle is going to be the smaller angle? All right, well, hopefully we remember from geometry, and we've talked about it a little bit this unit as well, that the smallest angle in a triangle is always across from the smallest side, right? And the largest side is across from the largest angle. And of course, then the middle angle would have to be across from the middle side. All right, so we know that because A is 11 and B is 5, right, we know that B is going to be the smaller angle. So I'm going to find B. So I'm going to use sine of B over side B is equal to sine of C over side C. Now I know that this is a rounded number here, but we don't have a choice. Okay, we have to use it. So if you have to, you have to. All right, so now to solve for B, we've done this before with our law of sines work. We multiplied both sides by 5. All right, so these will cancel. And then, of course, to break apart sine in B, you have to use inverse sine. So angle B will equal the inverse sine of this stuff. All right, so we can go ahead and plug that into our calculator. So we will get the inverse sine of the sine of 20 degrees. And actually, that's all times 5. So I'm going to put a 5 out here. You can put it in the numerator. You can put it out in front. It doesn't matter. It'll still multiply it just the same. And then this is 6.529. Whoops, don't want that there. I want it out here. All right, so what happened there? I must have made a mistake. I don't like that. Why did that become a mistake? Maybe it didn't like the 5 there. Hey, there we go. Okay, I did not like the 5 out front. So I guess that's order of operations wise, that shouldn't matter, but apparently the calculator does not like it. All right, so here, angle B is going to be 15.2 degrees. Remember, angles, we can round to 1 decimal place. Sides, we round to 3. All right, well, now that we have 2 of our sides, of our angles rather, we can find the third easily enough. 20 and 15 our 35.2. All right, so angle A is going to equal 100 minus 35.2 degrees. All right, and that is going to be 144.8 degrees. All right, and this does make sense, all right, because our largest angle is across from our largest side, all right, and our smallest side is across from our smallest angle. All right, had you actually found angle A first because it was an obtuse angle, it would actually mess you up. And if you checked, like, does my triangle make sense? It would not have. All right, so I definitely recommend that you always check, is your smallest angle across from your smallest side? Is your largest angle across from your largest side? All right, if it's not, that's probably because you tried to find the larger angle first. Now, sometimes you just get lucky and all the angles are acute, and then in that case, it wouldn't mess you up. All right, but if the angle happens to be an obtuse angle, all right, then it will kind of mess things up. So do be mindful of that. Okay, so here we have another example. All right, I recommend that you pause the video here, go ahead and attempt this yourself. All right, and then play the video and check your answers against my work. All right, so here we have B, C, and angle A. So that means we're going to be finding side A. All right, so we're going to be using A squared is equal to B squared plus C squared minus 2BC times the cosine of angle A. All right, so we're looking for A. All right, so we have 16 squared plus 12 squared minus 2 times 16 times 12 times the cosine of 80 degrees. All right, again, in order to solve for A, we would have to take the square root, so we have to do that to both sides. So we can get out our calculator here, and we can say, all right, the square root of 16 squared plus 12 squared minus 2 times 16 times 12 times the cosine of 80 degrees. We do that and we get 18.257. So A is equal to 18.257. Okay. So now we need to find one of our missing angles, either B or C. Now in this case, A, because A is our biggest side, we know A is our biggest angle, so we know that both of these are going to be acute, so it doesn't really matter which one you find, but I, just to get in the habit, would find the smaller angle first, just so that you always do that, so that when it is a problem, it doesn't become a problem for you. All right, so I will go ahead and use sine of A over A equals sine of C over C. So sine of 80 over 18.257 degrees, of course, is equal to sine of angle C over 12. All right, so again, we just multiply both sides by 12. All right, and then to solve for C, all right, we would just do the inverse sine of all of this stuff. All right, so we'll go ahead and say the inverse sine, all right, of 12 times the sine of 80 degrees over 18.257. Oops, again, don't want that there. All right, and we get 40.4 degrees. Well, now that we have two of the three angles, all right, we can easily find our third. 80 and 40.4 are 120.4, so this will be 59.6 degrees. And we have solved the triangle. Okay, this is an alternate form. Basically, all this does is take that original form that we've just been using and solved it for cosine of A. All right, that's all this formula is. This one will also be given to you on your formula sheet. All right, and we want to use this when we are given side, side, side. So if you're given all three angles, right, and just, for clarification purposes, see how we could use side, 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 or side, angle, side here. We want to use these formulas, all right, when we have side, angle, side, all right, and we want to use the alternative form, all right, when we have side, side, side. Also, you can flip this one around like we did the other ones, but you will never ever need to. The reason why is that if you're given all three sides, you're always going to have A, B, and C. So you can always find angle A first. All right, so you don't have to worry about flipping this around any ever, okay? All right, so here we are given all three sides, so we know that it's side, side, side. So we know that we're going to be doing cosine of A is equal to B squared plus C squared minus A squared all over 2BC. All right, so I do my cosine of A here. All right, I plug in my numbers here. So I'm going to have 8 squared plus 12 squared minus 6 squared all over 2 times 8 times 12. All right, now we don't really care about what cosine of A is. We want to know what actual A is. So of course, to undo this angle from this trig function, we have to use the inverse trig function. All right, so of course these will cancel out and we will get A is equal to, we use our handy dandy calculator here. All right, so we are going to say the inverse cosine of 8 squared plus, I believe it was 12 squared minus 6 squared all over 2 times 12 times 6, if I'm not mistaken. Yes. Oh, no, sorry, 2 times 8 times 12. Down. I'm an idiot. 2 times 8 times 12. All right, so 26.4 degrees. All right, well, once we've done that, we can use law of sines again to find one of the other sides. Of course, I have to use sine of A over A. Again, remember, we do want to be careful to pick the smaller angle just to make sure that it's acute and it doesn't mess us up. So we're going to be finding angle B here. So sine of angle A over side A is equal to sine of angle B over side B. So of course we just multiplied both sides by 8 here again. And then to undo this, we're going to have to do the inverse sine. All right, so we get our calculator out here. We say inverse sine of 8 times the sine of 26.4 over 6. And we will get 36.4. All right, and now that we have two of our angles, all right, we can find our third easy enough. So if we add these together, we're going to get 62.8. So C will be 117.2, assuming I did that math correctly in my head. right? Doesn't make sense, right? Smallest angle goes with the smallest side, middle angle goes with the middle side, and the largest side and largest angle go together. So it at least makes sense, so we're in good shape. All right, again, all right, here is a good place to pause the video, attempt this one on your own, and then play the video and check your answer against mine. All right, so again, we can go ahead and use our alternate form here. So cosine of A is equal to B squared plus C squared minus A squared all over 2BC. All right, so in this case, all right, cosine of A is going to be equal to 19 squared plus 14 squared minus 8 squared over 2 times 19 times 14. And of course, we don't care about cosine of A, we just want A, so we have to take our inverse cosine of both sides here. So when we plug this into our calculator, all right, we will get inverse cosine of 19 squared plus 14 squared, I believe it was 8, yep, minus 8 squared all over 2 times 19 times 14. And we get 22.1 degrees. All right, so again, now we need to use law of sines to find another angle. All right, we obviously have to use sine of A over A. Again, just to make sure that you don't get any problems, make sure that you're finding the smaller of the two remaining angles. In this case, that would be C. So I'm going to use sine of A over A equals sine of C over C. So sine of 22.1 degrees over 8 is equal to sine of angle C over 14. So of course I multiply both sides by 14. All right, and then I will take the inverse sine of both sides to get C by itself here. All right, so when we do that, we have the inverse sine of 14 sine of 22.1 degrees over 8, and we get 41.2 degrees. All right, so again, now that we have two angles, it's easy enough to find our third. 22.1 and 41.2 are 63.7, so that's 112.3. Again, assuming I did the math correctly in my head. Oh, I'm sorry, not 3.7. Oh, I'm a complete idiot. I didn't do that anywhere close in my head correctly. All right, so that's 63.3. Then it should be 116.7 degrees. And now we're good. Okay, so now we'll look into some other types of problems, right? Instead of just the straightforward ones, we'll look into some word problems here. So we have a parallelogram, has sides of lengths 3 and 5. In one angle is 50 degrees. Find the lengths of the diagonals. Okay, let's see if I happen to have a parallelogram in here. Doesn't look like it. Oh, yep, we do. Sweet. Okay, so we make ourselves a nice parallelogram. All right, and we know that we have lengths of 3 and 5. All right, and one angle is 50 degrees. Obviously, this acute one. Okay, so we do need to remember some things about parallelograms from geometry. All right, and one of them is that consecutive angles are supplementary. So if this is 50, this has to be 130. This also has to be 50, and this also has to be 130. And then, of course, this is 3, and this is 5. Okay, so we have to find both of the diagonals. All right, let's go ahead and find this diagonal first. All right, so now what we can really do is just look at this triangle. All right, so I will, let's just make that in green. So here to here to here. Right, so this is the triangle we're looking at now. Well, we have side, angle, side, right? So we can use law of cosines to find the other side. All right, so all we have to do here, I'll use green for this, so we can say a squared is equal to 3 squared plus 5 squared minus 2 times 3 times 5, all right, times the cosine of the angle that's between my two sides there, 130 degrees. All right, so of course we can simply just take the square root of both sides. We can plug this into our handy-dandy calculator. So 3 squared is 9, plus 25, minus 15, that's 30, times the cosine of 130. And we get 7.2295, so rounded to 3 decimal places, that's 7.300. All right, awesome. So now we want to find this other diagonal. And we'll use red for this. So now I want to find this diagonal. All right, well now we want to look at this triangle. Of course, you could do this triangle as well. It doesn't really matter. All right, so we'll just do this one here. And so I'm looking at this triangle. All right, well, if this is 5, then this also has to be 5. All right, so now I have 3 and 5 with the included angle being 50 degrees here. All right, so now I can find my opposite side. So I'm going to say a squared is equal to 3 squared plus 5 squared minus 2 times 3 times 5 times the cosine. This time my included angle is 50 degrees. All right, so of course I will take the square root of all of that. This will be much easier in our calculator because if you just hit second enter, it brings up what you just typed in. Everything is the same except for this angle, right? This is going to be 50. So we hit enter there, 3.836. And we just found both diagonals. Well, we are done. All right. Next. Yeah, those are pretty much exactly the same, these two. So we'll do one of these two. All right. We'll just do this one. So it says the pitcher's mound on a women's softball field is 43 feet from home plate, and the distance between the bases is 60 feet. The pitcher's mound is not halfway between home plate and second base. How far is the pitcher's mound from first base? All right, so it kind of gives us this picture here. All right, so here's the pitcher's mound. Here's home base. All right, and we know that this is 60 feet. All right, and we know that this is 43. All right, it tells us all right, that this is 43 feet. All right, so all we have to do is find this distance here between the pitcher's mound and first base. So we have two sides with the included angle between them, so that's side angle side. So we are going to be using, we are going to be using a squared is equal to b squared plus c squared minus 2bc times the cosine of angle A. And of course, my two sides are my B and C, doesn't matter which one you call which, and the included angle is my angle A. All right, so we will say A squared is equal to 43 squared plus 60 squared minus 2 times 43 times 60 times the cosine of 45 degrees. All right, so of course, to find the actual A, we would square root all of this. So now we can say the square root of 43 squared plus 60 squared minus 2 times 43 times 60 times the cosine of 45 degrees. And we get 42.430 feet. So 42.430 feet. And we are done. Right, this one here basically kind of is very similar. You're just going to set up a triangle. All right, but this time batter hits the ball to center field. The center fielder then throws the ball to third base. Right, the distance from the center fielder to home plate is 240 feet. The distance between the bases is 60 feet. Okay, how far did the center fielder throw the ball? So we can go ahead and do this. All right, so basically we have a diamond, which actually is a square, but just off to the side, right? I want this to be as identical as possible here. All right, so the center fielder, of course, is out here somewhere. All right, and he throws the ball to third base. So to here. Whoops. No. All right. The distance from the center fielder to home plate is 240 feet. All right, so we know that this is 240 and this is 60. All right, so we can start putting all of our stuff here. So this is 240. All right, this is 60. All right, and we know that here, assuming that he is straight into center field, all right, then we know we have to assume that this is 45 degrees, right? If this is a 90 degree, then cut that in half. This is 45, all right? So in order to find this missing side here, we just use law of cosines again, all right? I'm not going to go through all of this, right? Of course, we would just say, if we call this side A, then A squared would equal, it's eventually going to be the square root, right, of 60 squared plus 240 squared minus 2 times 60 times 240 times the cosine of 45. So you just plug that into your calculator, hit enter, and you're done. All right, two boats start at the same point and speed away along courses that form a 110-degree angle. If one boat travels at 24 miles per hour and the other boat travels at 32 miles per hour, how far apart will the boats travel after 30 minutes? Okay, so let's go ahead and make a triangle here. So we've got boats traveling here. All right, and just make this triangle here. All right, so the boats are starting here. All right, they're traveling at a 110-degree angle. Right, so this would be 110. All right, one's traveling 24 miles per hour. Well, if you're going 24 miles per hour and you go for half of an hour, then you're going half of this distance. So this would be 12. Same thing here, 32 miles per hour, half of that would be 16. All right, so again, we can call this A and use our law of cosines, right? So 12 squared plus 16 squared minus 2 times 12 times 16 times the cosine of 110 degrees. We plug that into our calculator. And you get 23.051. So, according to our multiple choice options here, C. And that is it for the day. Of course, your assignment will be on Delta Math. Have a good day, and I will see you tomorrow.